Hey guys, I'm Pat Kelly. Okay, for these problems, what they're going to do is give us a binomial to a certain power and ask us to find just one of the terms. So for us, we're looking for the third term. And what that'll really come down to is somewhat of a formula. You have a formula for the r plus 1th term. So I've started writing that, but I did not write the formula because I want to suggest to you that that's something you want to get going when you get your problem started. As a first step is know the formula. So you want to provide this for yourself. And what the formula will always look like is one of those binomial coefficients with subscripts n and then r, and then x raised to a power which is just n minus r, and then y raised to the r power. Okay, so you've got your formula, you've got your template to follow. All we need then is n and r and maybe even x and y. So let's go back to the original expression and get those values. First thing I mentioned is that we need n, and n is always your exponent of the binomial. So 5 for us. Okay, r, I had mentioned that we need an r for that formula. And be careful with r, because they tell us that we want the third term, or they want the third term from us. But 3 is not your r. Be careful and notice in the formula, the name of the formula, it's the r plus 1th term. So if you're looking to get the third term out of this, your r is actually 2, right? Because then 2 plus 1 would be 3, and that's going to give us that third term that they want. Be careful with that. I'm going to ask you to continue to be careful because we also need x and y for our formula. And the reason I'm suggesting to be careful is because I actually even put quotes around this, quote unquote x, quote unquote y. Because how you get these expressions for x, what you do is you go up to the first term of the binomial and just grab that guy. So that's x for us here, which is convenient for us, but just be careful because whatever would have been in that first term of the binomial, the whole part of it goes into your x. Like for instance, my y, I want to go to the second term inside the parentheses. Notice that there's a 6 there, but there's also even a minus sign there. And so I keep saying to be careful. I don't want you to lose that minus sign, nor the 6, of course. So my quote-unquote y is minus 6y. The entire stuff that I squiggly underlined up there in orange. All right, now I feel pretty good about getting back to that formula. So let's try to continue on in this problem. For us, that third term, I'm going to try to follow this formula, is going to be c with subscripts of 5 and 2. My x is just x. That's nice. My exponent for that is n minus r, so 5 minus 2 is 3. My y, that's actually the quote-unquote y. That's parentheses minus 6y, close parentheses, and then raised to the r power, which we had said r was 2. So 2 is the exponent for that entire parentheses. Okay, let's continue simplifying. This notation you've hopefully been practicing with. The first subscript becomes your numerator as a factorial. In your denominator, you do 5 minus 2 and get 3. Write that as a factorial. And also that second subscript as is, but as a factorial. And then x cubed still. Let's simplify this. Minus 6 to the 2 power. That's just going to be 36 y squared. And all that's left then is that binomial coefficient work, which again I hope you've been doing some practice with. 5 times 4 times 3 factorial. I stopped there because the 3 factorial downstairs will cancel. 2 times 1 for my 2 factorial. Those guys will cross out. The rest of this from the step above stays the same. And we're one cleanup step from being done. This equals, and let's see, 2 would divide with the 4 and give me a 2. 5 times 2 is 10 times the 36. Can do that without a calculator. 360 x cubed y squared. That would be the third term. Okay? Try some more on your own. I know you'll do well.